Okay, so maybe some of you saw the announcement we did about a month ago. It's a thing called ION. It's this layer 2 DID network that we have been working on at Microsoft and with others in DIF. That's the Decentralized Identity Foundation. ION is a way that you can have identifiers that you own. So let's talk about that a little bit. What's a DID? It might be the first thing you're asking. It stands for Decentralized Identifier, and it's a spec that's being worked on inside the W3C, DIF, and other places. And different from a username or an email or something of that nature, it lets you own the identifier or identifiers that you use in the world. So what you see here is actually the piece of metadata, the only thing that ION, this layer 2 network, cares about, which is called a DID document. It contains keys that might relate to devices of yours or other things, and endpoints that are tied to an identifier that you create, own, and control, and then no one can take away from you. So why did we work on ION? Why did we build ION? Maybe why is it on Bitcoin? Well, there's really this scaling trilemma out there with DIDs. It's really awesome to have an ID that you own and control, but some of the legacy methods of doing this, maybe using a Bitcoin address as your DID, that certainly are backed by keys, aren't very scalable, right? The network is not capable of transmissions at the rate that you might need to roll keys and get a new phone, that sort of thing. So we needed a better way, a way that was more scalable. And so we've come up with a purely logical protocol to do that. And really the protocol has to balance these three things, because if you give on any of those, it's not really worth it. Microsoft has a fantastic centralized identity business known as Azure Active Directory, which owns 95% market share in enterprise identity. Anyone who makes money in the world uses Microsoft Identity, they are our customers. So if something was as centralized as some other networks being put out by some other companies recently, it just wouldn't be enough of a value proposition. So it needs to have all three of these properties at once while being scalable. So let's talk about what the scope and scale of identity is, right? So 7.5 billion human beings on the earth, hundreds of billions of devices. Certainly a system of that magnitude, if each of them was just to have one ID, and we don't believe they'll just have one ID, we believe you might have many IDs, one per connection with other people in the world. That's an enormous load. So we needed a protocol that can serve that. What are the requirements for DPKI? So when I say DPKI, I mean decentralized public key infrastructure. Centralized public key infrastructure is what you have now today with DNS, right? Your keys, your ability to own a domain name is hinged on the fact that some signatory, some centralized authority has signed saying, yeah, this party owns this name. This system's taken advantage of all the time. But what if you wanted a DPKI system, one that no one could take advantage of, one that was anchored in a self-sovereign system like Bitcoin? Well, what you need for any DPKI system is an immutable linear chronology. So you need something that keeps track of state over time that no one else can control singularly or as a cabal. We want there to be no central providers or authorities in the system, and the system should be censorship and tamper resistant. So one key realization we had when we were working on the protocol is that DIDs are a little bit different than asset value transfer like Bitcoin itself. And this is the thing to remember here is that like you might send Bitcoin to someone, so you want finality and understanding that there was an exchange. DIDs never leave their owner. So when you create a DID yourself with the keys that are on your device that no other company or entity owns or ever controls, we assume in the protocol that you never transfer it or send it to anyone else. That's a huge thing to remember about this protocol because it unlocks some capabilities and some things we can do with the protocol technically that you can't do with other types of assets. So a little bit of a technical overview. So what is ION? So it actually stands for, because the lawyers told us it has to stand for something, it can't actually be a brand, Identity Overlay Network. It's a public permissionless DID network that runs atop Bitcoin using an implementation of a DPKI protocol we call Sidetree, which technically is blockchain agnostic. There is a group using this open source software to build one on Ethereum called Elements. ION is the Bitcoin instantiation of this network. There are no authorities in the network. You are not beholden to Microsoft. There are no signatories. You do not need to go through any validators. So some technical assumptions we made while building the protocol. One, there's no secondary consensus required. ION is not a sidechain. It is not a blockchain. It, in fact, the nodes in the network, anyone can spin up, sort of like lightning, spiritually like that. And they don't communicate to form an idea of what should be. That's all handled by Bitcoin itself. There's no conflicting states allowed in the protocol, so it is provably convergent. In the same way that you would have a blockchain, you could have a known outcome, you can have a known outcome on the second layer. IDs, again, are not transferable between owners. So what does it look like? Well, this is a picture of if there were 2 ion nodes in the network. It's kind of how it works. Other familiar protocols you might see, like open timestamps that batch things together and then anchor them. There is this similar feature in ion, but it's not for the purpose of publication at a point in time. What ion is more concerned with, and its nodes are more concerned with, is batching together DID operations, creates, key rolling, that sort of thing, and then entering them into a record in series. So it's not so much a point in time, it's where in time. And that's one key realization. So if node 1 here is to say, get some DID operations, either maybe you're running it locally and you're doing 1 or 2 operations, or you're sending your operations to someone like Microsoft who can't change them because they're already signed with your keys from your client. The worst we could do is say, we're not going to put it in. Then you could go to another node or run a node yourself. That first node is going to batch together operations and anchor them to the chain. Other nodes are watching the chain. They're essentially observing the chain, looking for values that match these leading bytes that say, this is a multi-hash that I should be concerned with. When it finds a transaction that has embedded one of these batches of DID operations, all the other nodes immediately try and pull and propagate that over IPFS. So they're all actively trying to replicate this data amongst themselves. Once they've gotten a batch, they perform a series of deterministic operations on the batches that link states together over time. So if Alice ground her ID at time 0, and she puts another operation in that might roll a key. Say she got a new phone, so she wants to disassociate one phone and associate another with an identifier. She would put a new operation in, and those 2 operations are provably convergent. So this is a little bit about what that looks like. So when Alice is doing her create over here on the left, she puts a small payload in that basically is her initiating document. It says, here's some keys tied to this ID. She anchors that in Bitcoin. There's 2 IPFS files. One is the anchor file, and one is the batch file. The anchor file is sort of like a control file. It's very small, whereas the batch file is the verbose data, the operation data that says what incremental addition or subtraction or modification in state of that document I showed you originally is Alice entering into the record. So all the other nodes are observing this happening, and they're pulling these batches and they're processing them all in the same way. It's sort of like Bitcoin, where if you change the rules, if you change the processing rules, like say, made bigger blocks, you would get a different outcome. You'd see a different network. So it's very important that all the nodes run the same rules. So what is, the slide's a little messed up, but what is the actual convergence method? So this is going to get a little bit technical. You can see me after. I have 6 more minutes to explain this to you. Here's a crash course. The sidetree protocol that underpins ION is a form of conflict-free resolution data type. CRDTs are common. You probably have used an application that uses CRDTs, you just don't know it. Whenever you type into a Google Doc and you start typing, there's other people typing. CRDTs are what logically allows all those changes to be merged into one document object at once. So what they essentially do is logically, they take a bunch of different stuff and they're able to give you a singular outcome. CRDTs are able to do that deterministic merging based on something that's even quoted, I think, in the Bitcoin white paper, Leslie Lamport's timestamps, or they're called vector clocks. Basically, multiple writers to an object or multiple vectors of writers increment a number, and that's how it proves a series. So basically, when you're merging in these state changes, you just have a numbers of writers that say, I came first, well, I came second, well, this came third, and you're trusting them. You're trusting that incremented chronology with when it happened in time. That's what sidetree uses, and that's what we use the blockchain for, is instead of just trusting some writer to an object to say, I'm incrementing a number, stick it in here, we're actually using the blockchain as a proof of position system in a linearized series. So what we're actually leveraging is the idea that Bitcoin blocks occur in a provable series, and we're replacing vector clocks with one global oracle that's a clock, and that's the progression of Bitcoin blocks over time. So what do we get out of this? We get a system that can create and update and manage DIDs at massive scale. We're talking thousands of DID operations per second across the network, cost efficient. Even if the price of Bitcoin goes up to 10 cents, or I'm sorry, $10, a writer of a node could anchor 20,000 high-value operations, distributing that $10 over potentially 20,000 people and the value that they're trying to add to the system. It's permissionless. So unlike some other networks you may have heard of recently, there are no authorities. Microsoft is not authority. You do not come to us. We will run a node just like others, but you can run one yourself, just like you can a Bitcoin node. And in fact, you have to run a Bitcoin node to run the protocol. And the nodes are flexible and differential in the sense that you don't have to download the entire state, and this goes back to that batch file and anchor file. You have to download a minimized file that's orders of magnitude smaller to remain trustless and be able to resolve any ID without the help of an authority. So somehow I made it in 12 minutes, under 15. This is what we're doing at Microsoft. The reasons are clear. I want to give you a little bit about our intent and why. We believe this unlocks a bunch of new business for us and other companies. We're not afraid of it being decentralized. We think that our current businesses like Azure Active Directory, which marshal current identities, centralized identities, federated identities, you still need to have those things in the world, because even if everyone brought their own ID, like we now bring our phones to the enterprise, there still has to be some sort of hierarchical systems that make sense of this employee answers to this employee. So they're always going to need services like that. We think we have a good, compelling offer there. But also, we're not motivated the same way other companies are. If you look at our revenue, where it comes from, the distribution across our products, we don't make our money by selling people. Some other companies do. They might be more afraid of a protocol like this. We're not. So that's kind of why we're using Bitcoin, and that's my presentation. Thank you.